Welcome everyone to Xamarin Dev Days Live. This is our huge virtual event. We've been running Xamarin Dev Days all over the world. In fact, we've had over 130 locally spread out, run by amazing user group leaders, developers in the local area, and we're super excited to team up with Channel 9 to bring you Xamarin Dev Days Live directly to you. This is amazing. So no matter where you're at in the world right now, hundreds upon hundreds of Xamarin developers are getting ready to not only learn what Xamarin is, how you can build beautiful native apps with C# in Visual Studio, but also later on today, I'll be joined by Seth, where we're going to do a hands-on lab. Xamarin Dev Days is really unique. We started Xamarin Dev Days 2 years ago, and it went from 20 events to over 130 events, now live streamed here on Channel 9, because we wanted to create a free interactive event where developers can come out and learn how to use their C# and .NET skills to build beautiful native apps with Xamarin. So all the Xamarin Dev Days events were completely free around the globe, just like it is here on Channel 9. But now, if you weren't able to attend, or perhaps you weren't able to join for a weekend event, it's here, now, on Channel 9. Additionally, every single session here today for the next 4 hours is completely recorded. So you're fine if you need to pause something, you need to come back later. 4 hours is quite a little bit of a long time, so we understand. But everything will be recorded, and it'll be all hosted here on Channel 9. So let me tell you what exactly Dev Days looks like. So how we're going to start out today is we have a little bit of an agenda. And I'm going to be first starting by giving you a quick introduction to Xamarin, a complete little 101 overview of how Xamarin works, what it looks like to develop with Xamarin. And then after that, we'll take about a 2 to 3 minute break in between each session, and Brandon Minnick will come on from Xamarin to show you Xamarin Forms, our cross-platform framework to build native iOS, Android, and Windows applications with XAML, with a shared user interface. Then we're going to be joined by Adrian Hall, who will show you how to connect those applications up to our Azure cloud. Then Brandon and I will be doing a short session, our fourth session of the day, on all of the cool, awesome things that we announced at Connect 2016 for mobile developers. And then finally, I'll be joined by Seth, and this is your time at home, essentially to join us and download our labs, where you can complete a full app walkthrough with us. So Seth Juarez will be joining me, and I'll be kind of walking him through building his first app with Xamarin. So the first few hours of the day will be kind of sessions getting you up started on building apps with Xamarin. And then Seth and I will be building this app from scratch. All right, cool. Now, right now today, all of the slides that you're going to see, all of the demos that you're going to see, and the hands-on labs are already hosted on GitHub. If you go to this URL, github.com/Xamarin/DevDaysLabs, you'll find all of the source material, all the slides in PDF form, and all the demos that you're going to see today that you can download and run. Some of them have some additional setup, like API keys that you may need to handle, but everything is right here, ready to go. Now, I'm going to kick it off today, and we're going to be taking a look at native iOS, Android apps in C# with Xamarin. My goal is to give you a complete 101 overview of everything you need to know of how Xamarin works, why would you want to use Xamarin, and how you can leverage if you're already building Windows applications to bring that shared C# code layer over. So I'm going to give you a complete overview, or we're going to take a look at some extensions, such as plugins for Xamarin. So you may be wondering, well, who is this guy? I haven't even really introduced myself. Well, I'm James Montemagno. I'm a Principal Program Manager of Mobile Developer Tools here at Microsoft. You can reach out to me anytime. The easiest way is just through Twitter at James Montemagno. That's also my GitHub. That's also my direct email. So if you have any questions after Dev Days Live, give me a quick email. Additionally, I'd like to mention that I actually have a weekly development show right here on Channel 9. It's called The Xamarin Show. That was the best title I could come up with, and it makes sense. I bring on amazing experts and people in the community building libraries, building apps, and all the amazing things we're doing here at Microsoft. You can go to aka.ms/Xamarin Show, and it'll take you directly to the Xamarin Show right here on Channel 9, or just go to the Shows tab. Every single Wednesday, we release a brand new episode. I also have a podcast called Merge Conflict that you can check out that I do with my good friend Frank Kruger at mergeconflict.fm. But let's learn about Xamarin, because I'm pretty great, I think. But let's learn about Xamarin and how to actually extend our C# skills to all these different platforms. Now, when you want to architect apps, there's a few ways of doing it, because you want to create beautiful native applications. So often you think, well, I have to build applications 3 times. I got to build it for iOS, I got to build it for Android, then I got to build it for Windows, and I got to go learn Objective-C or Swift, I got to go learn Java, and I got to boot up Android Studio or Eclipse, and then I got to go do everything in C# for Windows. And this does give you a native app, but you're not really sharing code. You have multiple teams. It's really hard to sim ship features across the board, so it gets really expensive really fast. So then you say, well, what if I do this write once, run anywhere? And this is what people sometimes think of when they think of cross-platform mobile development, which is essentially taking like all this code and shoving it into this like magic app generator box. And there's a lot of different frameworks out there to do this. And some are obviously more native-ish than others. But often this is just kind of running in a web browser, and you're not really getting access to the full native APIs of each platform. So I always like to say that you're developing against their API, not the API of the platform. That's where things are a little bit different with Xamarin, which is we're not this approach, this write once, run anywhere. We deliver beautiful native applications for iOS, Android, Mac, and Windows, and all the platforms that you can think about. So think of it like this. If I point this out here, is we have the shared C# logic layer. This is all of your business logic of your application. So your models, view models, RESTful service calls, SQL databases, things that are the same, all of your .NET code. Then we enable you to build a beautiful native iOS, Android, and Windows user interface and access every single API in there. So on average here, you're sharing about 70 to 80% of code in your applications. It's all your business logic. We have 2 ways of building user interface, and that's what I'm going to focus on first today, which is our traditional approach, which is building native UIs for each platform. And we also have Xamarin Forms, which introduces a shared UI code layer. It's sort of an abstraction of all the common UI elements. So you don't get access to everything, but you get the common things on each platform. And Brandon's going to be coming up after me to tell you about Xamarin Forms and how it works and kind of demoing some really cool apps. But let me walk you through, before we get into a code demo, exactly what that looks like. Well, you have all of your .NET APIs, things that we've known and loved for a long, long time. Things like System.io, Link, XML, Numerics Core. This is just a subset of .NET. Now, normally you would run .NET framework on a Windows machine, and you have to install it and all this stuff. But it could be on a device, like a Windows device or a tablet or a UWP application or even an ASP.NET website. So when I want to target that platform, I download an SDK and I get access to those APIs. But for a long time, this was always restricted to Windows. But with Xamarin, think of it exactly the same, but we've essentially brought all of .NET and everything that you love over to iOS and Android. So you have all of that .NET goodness, which really sets Xamarin apart from any other cross-platform tool. Because as this platform, you have all of .NET that you can access right away on an iOS device. Then you get access to every single API inside of iOS and Android. So if you want to access iBeacon, UIKit, Core Graphics, Core Motion, or any of the tens of thousands of APIs in iOS, and of course Android, you have access to them. And what we do is, we don't just expose these in some shim wrapper. We create these really powerful C# bindings around every single API. And these bindings add C# features like async await, lambdas, events, delegates, kind of things that you know and love as a .NET developer. So taking advantage of that power of what we love of C#. And we get full native performance. Everything compiles down into a native assembly that's running, so a native application. There's no web browser, nothing like that. Well, you can embed a web browser in your application because you have access to it. But every single screen is embedded. It's fully native. So on iOS, we do a full ahead-of-time compilation from C# down into an intermediate language, IL, down into LLVM bytecode, which is a standard that gets sent through the same LLVM compiler and optimizer that essentially Apple uses for their applications too. So you get a native ARM binary. But you have this .NET runtime, this little .NET runtime that's been optimized for iOS and Android and all the platforms. So truly anything that you could do in Objective-C, Swift, or Java, you can do it in C# with Xamarin. And that's true. If you can do it in the native approach language, you can do it in C# because we give you access to every single API. We even give you the same binding technology that we use at Xamarin to essentially take an Objective-C or a Java library and then bind that up and bring it in. You can literally say, oh, I have this jar. I can drag and drop it into Visual Studio. I can create my C# binding around it, and then use that in my Xamarin Android application. So if there's some really popular framework that you want to use or library, you have access to it. We have a whole team that's already done it. We've called these components for Xamarin. They take the most popular libraries and create C# Xamarin versions to bring into your application, which is pretty awesome. Now, we're always up to date. We've had same-day support for iOS since iOS 5, all the way up to iOS 10 and the dot releases. For Android, we've already shipped Android M and N support and previews for the brand new 7.1 version of Android, which is awesome. And of course, with Xamarin, it's more than just phones and tablets. When I started 5 years ago developing applications, it was just phones, really, and then tablets came out. But now you can bring your C#.NET code anywhere, whether it's Apple Watch, Android Wear, Apple TV, Android TV, any of these devices that can run an iOS or an Android application. You can take your C# code and put it on it. You want a C# application on a TV? Go for it. You want it on your wrist? Go for it. You want it in glasses? Go for it. Access to anything. That's the power of Xamarin, is that it's fully native applications with access to every single API. Now, a beautiful part, boom, it's included in Visual Studio completely for free, including Community Edition. If you already have MSDN in Enterprise or Pro or Visual Studio Enterprise or Pro, it's included. If you have the Community Edition, it's included. You just build up an application, you ship it to the App Store. It's your application. You're good to go. It's included for free. So if you already have Community Edition, you have it. When you install Visual Studio, it'll install right along with it when you go to Options. If you don't have it yet and you don't see the tools that I'm showing you, go to Xamarin.com, click on the download button. We'll handle everything for you, including all the Android SDKs and anything like that. Best yet, it's open source. When you go to open.xamarin.com, you can learn all about our open source initiatives. All of Xamarin that you're going to see for our tooling for iOS and Android, for building these applications, are open source. Our components are open source. Xamarin Forms is open source. We have a beautiful, amazing community of developers that are not only building extensions for Xamarin, but helping build a better Xamarin and better SDKs. Everything is under MIT, so check it out. All right, let's build an app. I'm super excited. So we can actually just dive into code. I want to give you an overview of exactly how Xamarin works before we actually jump in to what it looks like. And I'll tell you about my setup since you can see me on the screen here. So I have my Surface Book right here with my little Android there, I guess. There we go, and Henry's up here. And this is my Surface Book. I'm going to do all my work inside of Visual Studio 2015. We do have Xamarin support for the RC of 2017 as well, but I like to stick to stable here. And I also have my MacBook, my rose gold MacBook, if you will, sitting right here. Now, for Android development and Windows development, you can do everything on a PC, anything that you want. When you want to do iOS development, you can do most of it inside of Visual Studio without a need for a Mac or anything like that if you want to edit the core source code. But when you want to put it, look at the designer, or if you want to put it on a device or simulator, you're going to need to go and actually connect over to a Mac. And I'll show you how that is set up. So that's kind of my setup here. I just installed Visual Studio, and that's it. Now, I'm going to go into an app, but feel free, if you go to channel9.msdn.com, just go to channel 9. We actually have a live Q&A section. You can ask us questions interactively, so don't forget that. If you're live streaming and you have a question, it pops up literally right here and over here on these teleprompters. So just let me know, and I'll be looking at these questions along the way. So let me know there. So don't forget that. You can ask questions live. All right. So let's jump in really quick. I'm going to pull up my chair, and we're going to sit down. We'll get some cool picture-in-picture action hopefully going on here. So, all right, so I've installed Xamarin, and I'm here inside of Visual Studio. And this is our project dialog when you have Xamarin, normal Visual Studio. So here's Visual C#. When I have Xamarin installed, I'll see Android. So here's blank Android applications, an OpenGL game, WebView, Android Wear application. There's that bindings project that I talked about, some testing here. Under iOS, you're going to see things like Apple Watch applications, extensions to do really powerful things like broadcast uploading, custom keyboards, iMessage extensions. Like, you can do all of this stuff, all of these extensions with Xamarin. And of course, iPad and iPhone applications. And then even down here, we have tvOS. So if you're building a tvOS application, it's right there. You're good to go. Now, where you want to get started if you want to build a cross-platform app, when you go under cross-platform, you're going to see one of two things. This is a brand new, I'm in the actual alpha version here. You're going to see either cross-platform apps or cross-platform templates to create a brand new app. So that's where you will set up a portable class library or a shared project for you, and it's there. Now, at the same time, this is a good question coming from the audience, is if you have F# installed, other languages, down here, look. Android applications in F#. You can build everything in C# or in F#. So that's kind of a question along the way. You can see it here. Here's iPad, iPhone applications. And we have great documentation at developer.xamarin.com. So boom, there you go. First question answered. Cool. All right. So I've already created an application here. And the app that we want to create is an application that can go out. It can search the internet for any image, any keyword search that we put in. We're going to use Bing Search, which is part of Cognitive Services, which is an API that you can use and just send it a query, send it geolocation, anything like that. And what I want to point out here first is our model and how we've set up this application. So inside of here, I have a portable class library. This could be a shared project or a .NET Standard library. Inside of here, I have some references, so some other things installed. I have some MVVM helpers, JSON.NET, some NuGet packages essentially installed. So if I go into my Manage NuGet packages here, we can see I have installed some HTTP client, JSON.NET, some other plugins that we'll talk about here in a bit. But it's just a standard library here. Inside of here, if I right-click and go into Properties, we can see that this portable class library can be installed in a Windows 10 application, Android, iOS, a Mac application, and of course, ASP.NET. Now this application, I've structured it in an MVVM type of way. It's pretty simple, just a single screen application. But my model is an image search, and I have some Bing search services here. So essentially, when I look at the actual JSON that's returned to me, I get things like name and web search URL and thumbnail URL and host page and all these really advanced properties. And I've used JSON.NET here to essentially add this attribute on top, so a JSON property. So all of these models, whether they're coming from Bing Search or the ones that I've created, are going to be shared across iOS, Android, and Windows. Now inside this image searches, I've given myself a really easy API essentially to use, because the Bing results are huge. They're crazy. They're just like a big JSON blob. So what I only want is the thumbnail link. I want the image link. I want the file format and title. So I can put that in the user interface in like a grid, if you will. So I'm just going to write just some .NET code. So I'm going to go into my image search view model here. And we can see up top, I have a bunch of using statements like link and collections generic and JSON.NET and HTTP client. And let me just go ahead and pull this out here. And what we're going to see, I'm going to make this a little bit smaller there. There we go. What I want to show you is that I just have an observable collection of image results, which again is just that little class that I created with thumbnail, image format. And that's what I'm going to expose to iOS or Android. Then I have a method. It's an asynchronous task that'll allow me to go off onto a background task somewhere, query for images. And then here's the URL for the cognitive services. I'm using some C#6 string interpolation. I'm going to grab the first 20 images, and I pass it the query in here. So now we can just write some .NET code. So let's go in here. I'm going to say var client. I'm going to say new HTTP client. Now this client needs a header. So I'm going to make this a little bit bigger for everyone. There we go. There we go. So this needs a header on here. So I'll say default header, and I'll add. And here I have to add my subscription key, essentially. So here I'm going to say header key. And then I'll see header value. There we go. Perfect. All right. Now inside of here, now I can just go ahead and make some RESTful service requests. Essentially, just like any time you use HTTP client, use the HTTP request, grab a string asynchronously, and boom, you're good. So now what I can do is I can say, let me get the JSON, and I'll say await. So I'm going to do this on a background task. I'll say client get string async. And here I'll just pass in the URL, which is coming right from this Bing image search. Now once I have the JSON, I can go and get my result that's coming back. Now my result here is going to be a search result, which is the main loop that gives me all my images here. So I'm going to use JSON.NET and say JSON convert.deserialized object, and that's going to be of a search result, and just pass it the JSON. So with a single line of code, I get make a web request. With another single line of code, I use JSON.NET to deserialize it. I'm using the full power of C#6 and .NET Framework 4.5, all these great features. And now what I need to do is I need to fill my observable collection here. So what I can do is I can say var images, and we'll use link essentially to convert those Bing results into my own results. So I'll say result.images, dot select, and we're going to say new image result. This is a really powerful feature of C# that'll enable me to go out and essentially select a bunch of new images, that, convert these images here in real time. So it'll loop over these and select these images here. Yep, so I should be able to just come in and then say new result, and I'll say file format. Oops, sorry, I need to do one thing here. I'll say there we go, little lambda, and I'll convert that I to a new image result. There we go. Visual Studio tell me I'm doing it wrong. Now I can come in and say, hey, what is my context link? And that's going to be I dot, and I have all of the Bing properties here. So that'd be my content, or my, let's say, URL. That'll be my host page URL if I wanted to launch it. The image link will be I.URL, which will be my content URL. I can grab the thumbnail link. That'll be I.URL, thumbnail. What I can do here is I can also check against null. And if it's null, I'll say, hey, use the content URL. Let's give it a file format equals I.format. And then finally, the title. And that'll equal I.name. So I'm converting those Bing results into my own image results here. Perfect. Now all I need to do here is essentially take my images, which I have right here, which is an observable collection. I'm going to say images.replace range. So it'll remove everything and re-add it to images. So boom, just some C#.NET code that's in there. So nothing crazy fancy, just some C# code. And that's what I want to show is it's just C#.NET code that I can reuse. Now, here's what gets really cool, is I have down here all of my shared code, so my image search, and I have some Android code, and I have an iOS project. Let's start on our Android project. And the first thing here is to notice that I've installed all of those same, those NuGets that are in there. So we can see first that my image search is my portable class library with my shared code. I have some other things like all these plugins that are in here, an HTTP client, and a whole bunch of other cool things in here. And I can come in and say add reference. And here's my image results. I have all my assemblies coming in here. So here's all my system, .NET stuff that I can add. And then we have things like resources. So these are really important in Android. You have all your drawables like images. Layouts are going to be your Android XML, which is an XML markup language essentially for Android applications. And then we have values like our colors, dimensions, things like that. Now, when I double tap on this main Android XML, it's going to bring up our Android designer. I've already created this user interface, but I'll kind of walk through it a little bit here. Over here, I have a full toolbox. So I have every single Android native widget available to me. So if I actually want to add in a switch or a text or a calendar picker or a grid layout or any of these different things, I can go ahead and drag and drop them right inside of here, including custom controls from the Android support libraries. They're all here. I created a very simple user interface to essentially just bring in edit text or a way of searching. I have a progress bar and a button. And then down here, I have this recycler view, which is a way of doing grids essentially inside of here. And what I like here, and some of the questions of kind of modularity of these applications, that notice that all of my models and view models are separated into a portable class library, where all of my just user interface is in the iOS or Android project. And that's kind of the modularity that you have. So this screen has some source code behind it. So when I tap on source, we're actually going to see the Android XML. And essentially, it's an XML type markup. Out of the box, Android and iOS don't have an MVVM type framework or anything like that. When we talk about Xamarin Forms later, it's built right into the box. There's some really cool libraries like MVVM Lite and MVVM Cross that add that to Xamarin. But I'm just going to show you the pure out of the box Xamarin here to kind of answer a few more questions coming in. So we can see this is Android XML, and I have an edit text here, and I give it an ID of my query. I have a progress bar called my progress, and a button called my button, and a recycler view. So what I can do is every single screen has some code behind, and that is an activity. Let me go ahead and get rid of this toolbox here. And this activity essentially is the code behind for that page. So there's a main activity, there's a base activity, and then inside of here, I just go ahead and create, there's a recycler view, my image adapter, my image search view model coming from my shared code. And right inside of here, I can just create a new one. So I'm accessing that shared code. Now notice that I still have to go and get access to that recycler view, my layout manager to have a 2x2 grid, and my recycler view here. But here's what's really cool, is I can come in and let me first find that edit text. So I'll say, here's my query. I'll say find view by ID. I know it's an edit text, so we strongly type it here, and I'll say resource.id/my_query. That's what I named the actual element in the Android XML. Now what I can do is I can get my button, and I can add a click handler. Nothing too crazy. I've already got the progress bar here. So what I can do is I'll say var button, which is an OK name for that button, but I'll say find view by ID. It's a button, and I'll say resource.id/.myButton. There we go. And now, when I tap on button dot, I have access to every single Android property and event. And we C#ified them. So you can see here that the is layout direction, is opaque, like all of these properties are just auto properties that we've enhanced the Android APIs. So now what I can do is I can say click here, and I can add a click handler. So I'm going to add an async sender args here, a little lambda, so a little click handler here. And that's how we added in C#. So let me make sure I don't get rid of my typos. And there's my click handler. So now what I can do is I can just go ahead and start messing around with this native button. So I can say button.enabled equals false. At some point, I'll say button.enabled equals true. And then we can modify this progress bar state, essentially. So I'll just say visible here. Now what I need to do is call into my shared code. So I have about 100 lines of just Android code here. And I can just say, hey, await, view model, reach into my shared code. Let me go ahead and search for images async and pass it the query. So I'll say query, which is a native edit text here, dot text, the text property, and I can just trim it if I need to here. And boom, done. Now what happens in this case for that recycler view is I've added a little image adapter here. So when I go to that definition, we can see that I have created my image adapter. It has access to my view model. Every time that collection changes, it'll update itself. And all I do down here is I just set the caption. I use Picasso, which is a library to load images up, and boom, there I have it there. And I'm using C#6, like amazing features in C#6 to essentially get really optimized list views. And that's my code. That's it. And inside of here, we can see that Visual Studio in the debug menu has already found all of the Android emulators that are installed on my machine. These could be the Visual Studio emulators for Android that are powered by Hyper-V, or they could be the Google emulators or any other emulator or a physical device that you plug into your PC. So I can just go ahead and tap on this emulator and hit debug. And this is really important. So if I actually start adding some breakpoints here into my code before and after I make these calls, we can see it'll compile up my application. I have my Android emulator here, and boom, it starts up my Android emulator. I can search for cute things, and I'll say cute monkey. We'll say go. And now we can see that it's actually coming back into Visual Studio. And I have access, so this is enabled, it's false, my visibility. Here, my view states, I can go ahead and hit continue. It's going to go out, do my little query right here. It's done. We can see the text was cute monkey, my view model that's here. And then I can continue on. And then there's all my cute monkeys. Boom. That's inside of there. So I can scroll through, adorable, adorable. I can come into here if I want to say, hey, what are those JSON results that are coming back? Like I can debug into my shared code here, so I'll remove some of these breakpoints. We'll go ahead and say maybe cute kitty. Go. So now it's in the actual shared code. We can see the JSON that's being returned right here. So I can pull that up. Here's that JSON. And I'll show you how I generated those things as I opened up a browser and I went to JSON to C#.com, pasted that in there. Hit generate, and generates all my C# for me, which is pretty awesome. I always like to show that. That's pretty much amazing. And then, yeah, I have my classes. It'll convert it. So here's my result that's coming back. It's just normal debugging. Here's my 20 images, all my images coming in. And then we get our actual cats that are coming in. All loading, all super fancy using Recycler View. We have some car view, really great material design going on here. Right inside of our Android application. Very simple, but I'm sharing a bulk of my logic, right? My view models, my models, all my RESTful service calls. I only have to deserialize it once. So now here's what's really cool is I can start building this application for Android or for iOS. So here I have an iOS project. We have some references, the same thing that we kind of saw earlier. So I have my MVVM helpers, JSON.NET. I have Xamarin iOS, where all of my iOS namespaces will live. Down here, I have some resources like my launch screen and my iTunes artwork. And then down here, we have essentially a few different files specific for iOS. Our app delegate is the main start point of our application, where we have lifecycle events like finished launching, on resigned, a main window that I have access to. And then I have this main storyboard. And Android essentially has a screen by screen, a way of describing the user interface, where iOS has a storyboard, which is the entirety or a segment of your user interface. So what's happening here is that, if I pull out, is that this is going out and it's talking to my Mac currently to actually go off and connect and build my iOS storyboard design. And how that works is that up top in my toolbar, I have Android toolbars to open the SDK or command prompts, my device logs. And then here I'm actually connected to my Mac, so my MacBook that's here. When I tap on that, it'll find any of the MacBooks on the network, and over a secure SSH connection, it connects automatically. So there we go. So now I'm connected, and it's just kind of communicating back and forth, which is cool. So now if I pull back out, we can actually see our little user interface that we've created. But notice there's a navigation controller here. There is this image search, which has some text fields. It has a little spinner here, a search bar. Up top, we have a constraint system for auto layout support. Anything that you could do in interface builder is here. So now if I wanted to come into my toolbox, and I can scroll down here, and here, just like Android, we have all of our controllers, buttons, spinners. I can drag and drop them around. I get guidelines, all that stuff that you would expect. Now, this file here also has properties associated with it. So if I actually go here, we've gone ahead and put all the properties. Whenever I tap around onto these different properties, I have all the properties in the layout and the events that come in. So if I tap on the button, for instance, here, UI button, we have all the touch events that are here. And I haven't added any here, but they're here, and I've named it button search. So I can access that in the code behind. So let's do that. Each one of these pages is a view controller. And what we can see over in the bottom left is we have the view controller class. So I can go into view controller. There it is. This is the code behind for that page. Just like on Android, I have access to every single iOS API. So if I come in and say core, animation, Bluetooth, audio, I essentially have access to every single API that's inside of iOS, which is really awesome. So here I have a UI view controller. I have my image search view model. So this is essentially my actual shared code again. And then I just have some lifecycle events like view did load, memory warnings, and let's write some code. So I'm going to say button search dot touch up inside, which is a click handler in iOS. Again, plus equals an async, and I'll do some sender args inside of here, and we'll add a little lambda for a click handler. Now I can do the same thing, button search dot enabled equals false, but this is the iOS specific commands. Dot enabled equals true when we're done. We have a little activity indicator, so a little spinner, and we'll say start animating. And this is all going to happen on the UI thread, but handle all the downloading on a background thread, and then stop animating there. Awesome. So now I can do the same thing. I'll just say await, and I'll say view model dot search for images async and pass it the query. So we're going to say, where's my query at? Text field query.text, and I could trim it because it's a string, pass it in, done. The only thing that I have to do is I have a collection view or a grid of different elements. So I need to make sure that it knows to reload that data. So I say collection views dot reload data, and it'll reload that data automatically for me. Now here's what gets really cool is I can start mixing and matching around this different functionality, and I can access native APIs here. So if I wanted to say await UI view dot animate, notice right here, this is super cool what we do. We say dot animate, and we add an async method. By default, iOS doesn't have an asynchronous way of doing things, so we add it in here because we can do that. So I'll say over half a second, let's add a little animation, and let's fade out our collection view. Let's put it down on a new line here. And I'll say dot alpha equals 0. So add a little native animation there for me. Down here, when it's all done, let's go ahead and set the alpha back to 1. So accessing native controls, native animations, call into my shared code, handle all of my business logic, and then boom, come back and reload my data. That's it. I can set the iOS project as my startup. And what we'll notice in the top is that we don't have any CPU. We have iPhone or iPhone simulator. If I had an iPhone plugged into my Mac, then I could just go ahead and hit the iPhone, and my iPhone would plug in. But I'm going to select iPhone simulator. And notice that it shows me all of the emulators that are available on my Mac right here inside of Visual Studio. And that's through that connection to my Mac. So what I can do is I can come over to iOS and I can go ahead and rebuild fully. I always like to do a full rebuild, which will clean and rebuild my application. And this will compile it all up kind of locally. It does a local compilation on my C#. But then what it'll do is it'll do a remote debug compilation when I actually want to put it on a simulator or a designer. So we'll give it a few seconds here to do that. So a lot of people are asking about MVVM and structuring code. And I like to just use out-of-the-box MVVM. MVVM Lite is really good. It's a light framework. I actually highly recommend checking out the Xamarin Show. I have an episode currently on MVVM Lite with Laurent. I also have one on Prism for Xamarin Forms. And next year, early on, I'll have one on MVVM Cross, so check out those there. All the documentation is actually on the Xamarin website. That's another question I'm getting while that's compiling. Here is when you go to Xamarin.com, tap on Developers. This is everything that you could ever want to get started. It's the one place that I went 5 years ago, and I come again. Here I'm inside of 2015. You could be using 2012, 2013, 2017. We work with all versions of Visual Studio. So now what I'm going to do is hit debug here. This is going to start a remote debug compilation on this iPhone simulator. Now one of two things will happen at this point. If you're using Visual Studio Enterprise, we have the remote iOS simulator for Windows that'll start up, and that's what I'm in here today. Else, if you're in Community Edition or Pro, it'll just start a simulator on your actual Mac, and you can just start working away. This is our remote iPhone simulator for Windows. And here it's actually going to start up a full debug session for iOS right on my Windows machine. So here we go. There we go. So here it's already set to Cute Monkey. I can go ahead and hit search on here. It's going to go off and pull that. Now I'm on a Surface Book, so I can actually use my finger to kind of scroll through the images, which is cool. Just use my finger, which is nice because we have a touch screen. We send those commands over. And we can notice here I can come up. I can say, let me see a cute panda. I'll hit search again. Notice it fades out, and then it fades back in, and then we get some panda photos there. And we have the title that's all coming in, and we're specifying that all in our iOS application. You can grab this source code from that GitHub repository that I showed earlier, and we'll be showing that again throughout the course of Dev Days Live. So the same logic, right? So our models, view models, our RESTful service calls, about 80% of our application logic is shared right here in this application to go do this image search. I have a lot of other code in here to do some cognitive services, to do facial recognition, a whole bunch of other stuff. So it's a really cool example of what you can kind of do sharing some code. Now, let me jump back in really quick into some more details of sharing code. So when you want to share code, there's a few ways of doing it. One is that you can access and leverage essentially NuGet already. All these great libraries like JSON.NET and plugins for Xamarin and all these different Xamarin libraries are out there that you can access and pull into Visual Studio. Not to mention here, you're also going to see, hey, if you're on a Mac, it's OK. We have Xamarin Studio, and there's also the Visual Studio for Mac preview that's available today. So I've done everything here on a PC, but you can do all of this on a Mac too. Don't worry, no matter where you're working, PC or Mac, you're handled automatically. You can use Xamarin Studio on a Mac, everything, the same projects, same solutions open. So there's a few ways of sharing code. First, I like portable class libraries, which essentially give you a single assembly for multiple targets. The evolution of that coming would be .NET Standard libraries, which are also compatible already with Xamarin. Or also shared projects, which give you a way of just kind of file linking automatically, which are really nice. But we've done one thing that I want to use in my final minutes here to tell you how we've simplified development for Xamarin developers. Because when you think of development, you have this shared C# backend business logic. But what about all of this stuff here? Essentially those core iOS, Android, and Windows APIs. Things like battery, GPS, notifications, settings, text-to-speech, or just connectivity. Am I connected to the internet? Each of these platforms have different ways of accessing those native APIs. So what we thought is, hey, wouldn't it be cool if you didn't have to write and learn all of these different APIs? It's still good to learn them and see how it's working. But what if you could access the native APIs from your shared code? What if you could say take photo in your portable class library, or check connectivity, or open a dialog box? What if you could just use text-to-speech and say speak hello world? And when you called that native API under the hood, it would actually go ahead and call AV Speech Synthesizer or text-to-speech. Well, we did that. It's called plugins for Xamarin. You can go to xamarin.com/plugins and learn all about them, how we've abstracted all of these platform-specific APIs into a common cross-platform API. Let me show you how this works really quick into this application. So for instance, let's say that I wanted to access, I don't know, let's go to the plugin page. So I go to xamarin.com/plugins. I can learn about how plugins work. And I can say browse plugins for Xamarin. It'll take me to the GitHub page where we have our open source components, our bindings. Then we can actually browse through the open source plugins for Xamarin. A lot written by Xamarins and people and developers at Microsoft, but also by the amazing community of Xamarin developers. So calendar, connectivity, device info, fingerprint, dialog boxes, playing back audio, all the Microsoft band integration, permissions, settings, sharing, sockets, it's all right here. So here's what's really cool is let's say connectivity. We can open the GitHub page and here's built by me. That's pretty sweet. And the API is really sweet. We can go in and see that we have iOS, Android, Windows Phone, UWP support. And you can just say cross-connectivity.isConnected. There's another plugin called Dialogues that can pop up dialog boxes. So let me show you how you would use this. You go into your actual solution, let's say Manage NuGet Packages. And here you can search for anything, but I've gone ahead and installed already the connectivity plugin for Xamarin into all of my projects because the abstraction lives in the portable class library, but the actual Android and iOS implementation lives there. Let's go into our shared code, into our view model. And what if I wanted to say, hey, if you're offline, pop up a dialog box. So I could go now and say, if I'm not cross-connectivity.current.isConnected, if I'm not connected here, maybe return false out of this. Let's go ahead and pop up a dialog box. We actually do it down here, so let's go ahead and copy this. And I can use user dialogues, which is a cross-platform plugin, and I'll say, hey, alert the user that you are currently offline. There we go. Now, on iOS, Android, or Windows, it'll go ahead and find and use the platform-specific implementation. And the same thing here, pop up native dialog boxes for iOS and Android. Let's go ahead and run it one more time here on the Android emulator and actually get it running. So here it'll actually recompile up my application with just 2 lines of code. I'm checking connectivity. I could register for different change notifications here. I can add breakpoints into here, and we'll see that if I just go ahead and tap on, let's say, cute monkey, we'll go ahead and hit go again. And now in this instance, it will actually go off and find my monkeys. But what if I put it in airplane mode? Let's go ahead and hit airplane mode. I'm offline. I'll go ahead and hit search again. Notice that I've now hit my breakpoint. I'm no longer connected to the internet. I'm going to pop up a dialog box. Currently offline. 2 lines of code to check connectivity and open a dialog box from shared code. And there's hundreds of plugins available on NuGet to pull into your iOS, Android, and Windows applications and start accessing all these native APIs from shared code. All right, so that's me. That is native iOS, Android development. I have a minute here of going through and answering a few questions. I have about 1 or 2 minutes left. So the first thing we'll say is, let's see, does VS for Mac have the Mac agent like Xamarin Studio? Absolutely. So if you install Visual Studio for Mac, it's going to install the alpha versions of everything Xamarin. You want to make sure you sync up your versions, and we have guides on how to set up Visual Studio for Mac here. Our stable would be Xamarin Studio and things like that. The same functionality for building iOS, Android, and Mac apps in Xamarin Studio is available over in Visual Studio. Chris asks, can you show and quickly explain Android SDKs? Which did you install? Sure. So we can handle everything for you out of the box. But if we jump over to Visual Studio really quick, we can actually go into Tools, Android SDK Manager. And when you install Xamarin, it'll handle essentially all the stuff that you need to install automatically for the current version that you have. And we have some guides on what you need to install. But essentially, I've installed Android API 24. That's in here. I'll zoom in really quick. I've installed the latest SDK tools, build tools here. This is really good to go and listen and read the documentation on. But out of the box, we'll install the Android versions you need. I haven't installed 25 yet at this point, but I can if I'm on the current alpha that's there. Cool. Awesome. Some people say awesome, that I'm pretty fantastic. I appreciate that. That's really great. Thank you. Check out Channel 9 on the Xamarin Show. Up next is Brandon minute, he's going to show you how you can use Xamarin Forms to build a cross-platform native user interface for iOS, Android, and Windows. I hope you've enjoyed this. I'll be back in a little bit with Brandon and then with Seth. So we're going to take a quick 2 to 3 minute break while we get Brandon set up. And sit tight and for more Xamarin Dev Days Live right here on Channel 9.